Hey everyone, so today we're going to do letter tile possibilities. It's question number 1079 on LeetCode and it's medium difficulty. So the question goes, you have a set of tiles where each tile has one letter printed on it. Return the number of possible non-empty sequences of letters you can make. So really what this is asking is, given a string, what are all the possible sequences, all the possible subsequences of the string? And if we notice in example 1, it says, okay, possible subsequences are A, B, A, and BA, AAB, ABA, BAA. And so you notice that AB and BA are not considered the same subsequence, and this makes sense because they're different strings. Okay, so the question is asking for the number of possible subsequences. So what we should do is basically generate all the subsequences and then just count how many there are. I think that's a solid approach. And let's get started. If you want all of the possibilities, say, okay, possibilities equals self.get tile possibilities, right? And then here we're going to say return the length of this possibilities, right? And that would kind of, if this get tile possibilities returns all the subsequences that are unique, then this kind of wrapper function for the solution should work. So I'm not entirely sure how I'm going to go about getting all these possibilities, but in general, for questions I've done that involve subsequences, I usually will pass in the the options. So in this case, tiles, the set of all unique subsequences we've found so far, and the current subsequence we're working with. So let's see how that plays out. So let's call this get tile possibilities. It's going to take self tiles possibilities. No, let's call it, what should we call it? Scene subsequences, right? And then current string. Okay. So first things first, we need to run some validations. Okay, so if there are no tiles to even deal with, all we're left with is what we've seen so far. And so we'll return scene subsequence, which if there's no tiles in the first place, it'll just be empty, and so we'll return 0, which works, right? That's a good edge case to cover. And then what we want to do is basically call this function recursively and eventually return the scene subsequence that has all of the subsequences in it. So each time we call this function get tile possibilities, we want to basically do a few things. We want to add, so for each available tile, right, add it to the current substring, add that substring to scene sequences if it's not there already, and then recurse with that tile removed, right? That's what we want to do basically. So let's do that for tile in tiles, right? We want to say let's just call it current subsequence equals current string, or whoops, actually, for index and tile in enumerate tiles. We're going to do current string plus tile. What do we want to do after this? We want to add it to the current substring, add that substring to the scene sequences. Okay, so scene subsequence dot add current subsequence. The cool thing about using a set is that when you try to add an existing value within the set, it won't do anything. So this kind of ensures that we have unique subsequences in the same scene subsequence set. And then the last thing we want to do is now call this recursively. So get tile possibilities on, now we want the tile options minus the one we just used. So I think we can do like tiles up to index, from index up to index, and then plus tiles index plus 1 up to the end. Right, so that'll be our new option array. And we have scene subsequence, so that's what we just added to, and current substring, so current subsequence. And I think this satisfies what we just said. So if we just run this, let's see what happens. Okay, sweet. So yeah, that works on that input. Let's run it on example 2. Cool. And let's run it on the empty string. No. Ah. Cool. So this looks good to me. Let's submit it and see actually how it behaves. Let's give it a shot. Bang, bang. Okay, so good, right? So this works. So thanks for walking through this with me. Hope this helps. This is a good pattern to use when you're dealing with subsequences and string building and options and permutations. So yeah, add it to the toolbox. Thank you.